So in the previous video, I demonstrated how I recomputed DLD kernel 2, which is this one here, and also I fixed the convolution function. But this time I created function called Deconvolution and MaxUnPool, which do exactly inverse of what MaxUnPool and convolution do. For instance, you pass some input to the convolution and you get some output. If you pass that output to the deconvolution function, you'd get what you pass to the convolution function as an input. Same for MaxUnPool, but you wouldn't get exactly same input as you pass to the MaxUnPool and convolution. Anyway, this is how you and the reason I created those functions is that first, those functions are present in famous machine learning libraries like PyTorch and TensorFlow. In TensorFlow, it's called Unsample 2D for MaxUnPool. I don't think TensorFlow has the deconvolution, but in PyTorch it's called Conv transposed 2D if it's to the dataset. Anyway, the reason I created this function is that I'm still computing gradients, and up to here the code looks pretty neat. I mean, it's easy to understand, but from here to here it's getting kind of messy. I'm still able to understand, but so this code could refactored as MaxUnPool, so and I'm already using deconvolution here. So how this deconvolution works? First, I pad the input given to this function, in this case DODC3Z, which has 10 by 10 matrices, into 18 by 18 matrices. So I padded this tensor with zeros on the left, right, and top and bottom in order to transform 10 by 10 matrices into 18 by 18 matrices. And the padding size is determined by the kernel size I passed to the function, which has, in this case, 5 by 5 kernel. So the kernel size is 5, and I subtract 1, and so padding size is 4. So that I padded this tensor into 10 by 10 matrices into 18 by 18. I do this because if I convolve this padded version of input with newly created transposed kernel, I will get a output which has same shape as S2, which is 6 by 14 by 14, and that's exactly what I wanted to get, because I'm trying to compute DLDS2. DLDS2 and S2 have to be, I have to have same shapes. So after I padded the input, I want to transpose the kernel that was given to the function. So this is the kernel. So I swapped the first and second dimension so that it would become 6 by 16, and I also swapped the second last dimension and the last dimension. It's still 5 by 5, but if you think about this as a normal transpose, if you think about this as transposing matrices, I think, yeah, it's easier to understand. So after I padded the input and transposed the kernel, I used them as an input to the convolution, and I take convolution. Then I'll get an output which has shape as same as S2. So that's the deconvolution, and it's pretty neat, because if I hadn't had this function, I would have all these functions floating here. It's, yeah, I guess this is much clearer. It's better. So how does this MaxUnPool work? So this is an example from example using PyTorch. So this is the input to the MaxPool, and this is the output you would get if you pass this as an input to the MaxPool. So you pick the maximum value in this region, which was 6, and in this region it was 8, in this region it was 14 and 16. And if you pass this output back to unpool function, you would get not exactly same as the input you pass to the max pool, but all the non-max values are zeros, and all the max values stays exactly where it was, where it were. So this is how MaxPool works. And so I passed I also changed the MaxPool, where I not only returning the tensor, but I also returning the indices where max values were, and I passed that to the MaxUnPool. So this is the input to the MaxPool, and this is the output. In this region it was 51, in this region it was 99. And if you pass this to MaxUnPool, I mean, the thing I'm doing is a bit different because I'm doing gradients and I'm not going to pass the output from MaxPool, but instead I'll pass the DLDS4, and DLDS4 looks like this, and each element in DLDS4 is determined by the indices of max values that was in the input given to the MaxPool. So in this region it was 51, that was the max value. But this DODS4, and so 51 the value 51 corresponds to value 2. So I placed 2 where 51 was, so it's here, same as 99. This time it would be 82, so I look for where 99 was, it was here, so I placed 82 to where 99 was. So, and this continues. So that's how MaxUnPool works. So now I'm gonna use this MaxUnPool where it needs to be used, like here, and I think I'm gonna refactor the code base, and I think I calculated gradients up to here now, and now I created MaxUnPool function. It would be easy to take gradients respect to C1, and also since I created deconvolution, it would be easy to calculate gradients respect to kernel 1. And so I hope I will finish this project soon. So I think this is it for today's video. Thanks.